Hi there, grade 8. Our lesson for today is permutation. But before I begin with my lecture, I'd like you to click the subscribe button for you to get notified whenever I upload new lecture video. So, as what I was saying, I'll be discussing a permutation. A permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of arrangements matters. Now, basically, permutation is considered as an ordered combination. And again, it's an arrangement of objects in a particular way or order. Now, we are using this formula whenever we calculate for permutation without repetition. And later, I'll be discussing the different types of permutation. And this is read as permutation of n taken r equals n factorial all over quantity n minus r factorial, where n refers to the total number of elements in a set, r as the numbers of selected elements arranged in a specific object. So common mathematical problems involve choosing only several items from a set of items with a certain order. So in that case, R is less than N. Now, this exclamation point is a notation for factorial, and you're familiar with this since I was able to introduce factorial last meeting as I introduced the principle of counting. Now, for example, the permutation of set P here with elements A, B is 2, such as AB and BA. Now, since in permutation the order of arrangement matters, so AB is a different arrangement from BA. Although we have the same two elements there, but really the order matters. When we look at the schedules of trains, buses, and the flights, we really wonder how they are scheduled according to the benefits of the public. Of course, the permutation is very much helpful to prepare the schedules on departure and arrival of these. Another, when we come across license plates of vehicles, which consists of few alphabets and digits, we can easily prepare these codes using also permutations. Now, we will be solving problems on permutations, particularly with the different types of permutation. So there are different types of permutation. One is permutation of n different objects when repetition is not allowed. Now, if n here is a positive integer, n is element of positive integer and r is whole number, such that r is less than n, then permutation of n taken r here represents the number of all possible arrangements or permutations of n distinct objects taken r at a time. So in case of permutation without repetition, the number of available choices will be reduced each time. So that's why in the permutation formula, factorial is introduced. So in solving for permutation of n different objects when repetition is not allowed, we're using this formula. Okay? N factorial all over quantity n minus r factorial. So later we'll be working on example problems involving with the first type of this permutation. Now, when permutation where repetition is allowed, so we can easily calculate the permutation with repetition. The permutation of objects can be written using the exponent form when the number of objects is n and we have R to be the selection of objects. So choosing of an object can be in n different ways. So we have the permutation of objects when repetition is allowed is equal to n times n times n. So this is up to R times. So therefore, permutation when repetition is allowed is equal to n to the R. And lastly, permutation when objects are distinct or we call it as multisets. Okay, for a while. So here, this is n to the R for number 2. Now, permutation of n different objects when, for example, p sub 1 objects among n objects are similar, and then p sub 2 objects of the second are similar, and then p sub 3 of the third kind are similar, and so on until p sub k, until p sub k objects of the kth kind are similar. So, and the remaining of all are different. So, thus, the permutation here of n taken R is equal to n factorial all over p sub 1 factorial times p sub 2 factorial times p sub 3 factorial up to p sub n factorial. Now, let's work on problems involving the three types of permutation. So, in number 1 problem, we are asked how many three-letter words without or with meaning can be formed out of the letters of the word proud. Okay? When repetition of letter is not allowed. So, let us identify the given first. So, we have n equals 5 there since there are 5 letters in the word proud. And we're going to take 3 letters from the 5 letters with or without meaning. So, our R is 5. So, since we have to frame 3-letter words again with or without meaning and without repetition, so therefore the total permutation is permutation of n taken R equals 5 factorial all over quantity 5 minus 3 factorial. So this is equal to 5 factorial all over 2 factorial, which is equal to 5 times 4 times 3 times 2 factorial all over 2 factorial. So this will be cancelled. So 5 times 4 times 3 is equal to 60. So we have 63 letter words with or without meaning can be formed out of the letters of the word proud. Next. So example number 2, how many three-letter words with or without meaning can be formed out of the letters of the word bread when repetition of words is allowed? Okay, so the number of objects in this case is 5. So n equals 5. as the word bread has 5 letters and R equals 3, as 3-letter word has to be selected. So thus P here is equal to N to the R. So we have 5 cube. So there are 125 3-letter words can be formed with or without meaning if repetition is allowed. Number 3, how many ways can we order letters in Mississippi? So in the problem, we have, take note that we have 4 I there, and then we have 1 M, we have 2 P's, and we have 4 S. Now, our P sub 1 here equals 4, P sub 2 is 2. You can assign any among, which is P sub 1, P sub 2, P sub 3. And then P sub 3 equals 4. Now, you may or you may not assign P sub 4 to 1 since that would mean 1 factorial. Okay? And take note that N equals 11 here since we have 11 letters in the word Mississippi. So, permutation of 11 taken or permutation of N taken R here is equal to N factorial all over P sub 1 factorial times P sub 2 factorial times P sub 3 factorial. As what I was saying, you may write P sub 4 here, but it's 1 factorial. So the product will remain the product of P sub 1, P sub 2, and P sub 3. So this is 11 factorial all over 4 factorial times 2 factorial times 4 factorial. So we have 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1 all over 4 times 3 times 2 times 1, 2 times 1, and then 4 times 3 times 2 times 1. So canceling the common factor, okay, so we have 4 and 2 that equals 8, and we have 3 and 2 that equals 6. So everything is canceled on the denominator. So we'll just have to get the product of 11, 10, 9, 7, and 5. And that equals 11 times 10 times 9 times 7 times 5 equals 34,650. So there are 34,650 ways we can order the letters in Mississippi. So this is about multi-set. Okay, example number 4. A president, a vice president, a secretary, and a treasurer will be chosen from 15 members of the mathematics club. In how many ways can this be done? Okay. Take note that in the problem, it was not stated as repetition or is not allowed or repetition is allowed, but you have to analyze the situation that we are selecting officers here. And the selection of vice president, of course, is not repeated, as well as vice president and the rest of the position. So in here, permutation, we're working on permutation when repetition is not allowed. And n equals 15, while since we are selecting four positions, so r equals 4. So permutation of 15 taken 4 is equal to 15 factorial all over 15 minus 4 quantity factorial. So this is 15 times 14 times 13 times 12 until 11 factorial, because the denominator is 11 factorial, and this will be cancelled. So the product of 15, 14, 13, and 12 is equal to 32,760 ways. And there are 32,760 ways of selecting these four positions. And example number 5, in how many ways can a 6-digit ID number can be done if repetition is allowed and 0 is not included in the selection of numbers? So we will begin from 1 until 9. So there are 9 numbers from 1 to 9. So our n is 9 and r is 6. So this is equal, permutation of this number is n to the r. So we have 9 to the 6. And 9 to the 6 equals 531,441. So there are 531,441 ways we can arrange 6-digit ID number when repetition is allowed. So we're done with permutation. Next meeting, I'm going to discuss combination, and we will compare the difference between permutation and combination. So that's for now, grade 8. See you